Okay. Thank you, Soumya. So welcome back. So today the arrangement is a little better, I think. So first, for starters, I moved to the, as promised, I moved to the seminar room now, and I use a podium, so the angle is changed, and I'm using the IAC LAN, so it is expected to be more stable. And next week I'll get a full HD camera, just in case I want to write on the board. All right. So we are still introducing data science. Okay, but this honeymoon is going to get over, and unfortunately, I'm going to get into some hard math, but not today. So I didn't want to scare you with math, and so you won't see at the end of the short course. The difference between lecture 1 and lecture 13 will be incredible. But if I show you the lecture 13 now, I think from next class onwards, most of you will not join. All right. So I'll not make that mistake. So we always proceed from the simple to the complex. Somebody is on the chat box. Who is that? Soumya. Yes, sir. We can start. Yes. Yes, we have started. All right. So we will go through some. There is some terminology which these data scientists use, and which is also used to scare the other community, the non-CS community, and all that. So the whole idea of this course is to demystify data science, so that scientists and engineers, we can use it without fear. All right. Many of these techniques we already know, but the thing is, when a lot of data is coming in, we need to be a little more organized. We just can't put them on an Excel or just run some MATLAB code, and sometimes there could be missing data, there could be noisy data, there should be corrupted data and all that. So when a lot of data is available, so you want to use them, process them. You also have simulation data, you also have modeling, you also have experimental data. How do we deal with this? That's what we are going to do in, that's what you're planning to do in this course anyway. So today the lecture will be focused on data. Okay, the whole lecture will be on data. What is this? How can one lecture be on data? Some of you may be wondering. Please keep wondering. So let's start. Slideshow. Why wouldn't it go? Is it in slideshow already?
No, sir.
No. Why isn't it going to slideshow? Last week also there's a problem. Pradeep. Can somebody help me out? Why is it not going to slideshow?
To press that resume slideshow. I think it's already, it's not showing.
No, tell me something. What should I do now?
I guess when you shared your screen, you shared the window of the PowerPoint. Maybe if you share full screen.
Okay. Stop share. Share. No, you have to say share full screen.
Yes, sir.
Again, I'll just stop share. Now share screen. No, it doesn't come. No, where is it? Share. It does. Has it come?
Yes, sir.
Yes.
Very good. Okay. Now let's start. So already I'm not able to see how many people are there. All right. So this is the course data-driven methods in machine learning, atmospheric science. So we'll complete the introduction, like introductory part, and then we proceed to data. Okay. Consider this problem of no. So consider the. So this is the problem number 1 of the course. Okay. So I believe in tutorial style of teaching. If some of you have watched my lectures on optimization or atmospheric science or whatever, I feel that the best way to teach a course is through examples. So we'll do a lot of examples in this course. Basically, at the end of today's class, we will have done 3 examples. Let us take the first example. Consider the data showing 15 observations of people's heights and weights. Analyze the data using the visual best method and any scientific data analysis tools familiar to you. I come back again. It's just a data with 3 columns. The first is the observation number, that is a counter. The second is the height in centimeters, first decimal place. And the third column is basically height of these people. Okay. Now you're going to have fun with this data. How to have fun with this data? Now, basically, if you don't know anything, you just know very simple statistics. So before that, even before that, you'll take the counter 1, 2, 3, 4, 5, 6, 7, 8 up to 15. That will be on the abscissa or the x-axis, and the height in centimeters will be the ordinate or the y-axis. You just plot 1, 2, 3, 4, 5. And now, if you see that it is a straight line, then you go back. Yeah. So therefore, it is not only a structured data because it is available in tabular column. It also seems to be very ordered. So it is in the ascending order of heights. Therefore, I can say more about the data by just looking at the plot. Okay. All right. Okay. Now let's go to the weight. Okay. The weight is varying from whatever 50 to 75 or whatever 72. And now, if I don't know any high funda statistics, what I will say is the mean sigma yi. Don't complain or crib. You have to tell that, sir, it is visible. Sorry. Is it visible? What I wrote on the board?
So partly visible.
Partly. Why partly? Why are you cribbing? Partly means what is it? You're not able to see it properly. It's small, or the light is an issue, or the camera is not good.
So, but it's manageable.
Manageable. It is better than last class.
Yes, yes.
Are we progressing in life? All right. So if you don't know anything, so you will just say that this is the mean. Okay. What is the fun in having this mean? So you will say that I'm not a great data scientist. So what I can say is, out of this 15, you can, if you want to present this data little more scientifically to some outside audience, somebody, a layman or something, you can say that the average height of this sample is 165.1 centimeter. Then there is the next one. We'll go deeper into this in later classes. Then there is something called standard deviation. Okay. So this standard deviation is nothing but yi minus y mean whole square, I equal to 1 to n by n minus 1. Yeah, here. Okay, this is variance. Standard deviation is sigma. So this is called the variance. Okay. Now, what this says is, you take the height of every individual, subtract 165.1 from it. If it is lower or higher, it doesn't matter at all because we're going to square it. So the sum of the squares of the differences with respect to some mean. The mean 165.1 may not be 1%. It is something which is going on in our minds, which can often be stupid. Okay, but we want to get a handle on the data. So we are talking. So please note that there could be, I don't know, I didn't look at the data set. There can be nobody with 165.1, but that's supposed to be the mean of the population. Okay, mean of this data. So if you take the difference with respect to the mean, square it, and there is one n minus 1. That why that n minus 1? Let's not get into high statistics now itself. I can tell you later. I think if my memory serves me right, it's n minus 1 because already one parameter has been used. So you'll have to the number of degrees of freedom is n minus 1. I think I'm good. Okay. Anyway, if n is very large, it doesn't matter whether it's n or n minus 1. So what you can say now is, cutting a long story short, 165.1 centimeters is the average height, and there is a standard deviation of 11.4. What does a standard deviation mean? If there is a large number of samples, it is expected to follow what is called a central. There is something law of centrality, or it follows what is a. Okay, it follows what is called the Gaussian distribution. So it will follow. It is expected to follow a distribution like this, where this is your y bar. So if you take plus 3 sigma and minus 3 sigma. Okay, so this is y bar minus and this is y bar plus 3 sigma. You can get all the data within this plus or minus 6 sigma. In fact, the GE company will say 6 sigma black belt, and 6 sigma means that more than 99% of the data is expected to be within this. All right. Therefore, you can say that on an average, I can expect that 99% of the time, somebody's height will not go out of 165 plus or minus 34.2. That is 11.4 into 3. So this is something much more than This is something much more than just taking this or tabulating this, putting it in ascending order, putting it descending order, um, and just plotting it on a scale and so on. So now we are able to do better than this. So this is the first level of statistics. So this is the first level of statistics we are doing. This is also data driven. So statistics is all about data. Probability, in probability you keep on doing theorems and you don't work with data. First, that is the difference between probability and statistics. Though many laws of probability will be applied in statistics. Along with statistics, you do a lot of computation to find out the distributions. It becomes computational statistics. So the computational statistics is moving towards data science. When you've got large amounts of data and you've got a lot of issues with the data, and there are other attributes to the data which not only scientists want to explore, business analysts, policymakers, economists, social scientists, healthcare workers, doctors, all these people want to get. Why should it be only restricted to the domain of science and engineering? That's how it has come from. Okay, that's how we have proceeded from the basic laws of probability and statistics all the way up to data science to it, and now to AI, artificial intelligence, machine learning, which will come towards the end of the course. Now go to the right side, this east second half of this plot, which basically does the same analysis with regard to weight. So you can see that the average is 62.02, but the 62.02, though my student faithfully, Pratik, my PhD scholar, he's a smart guy, though he has faithfully done it. As an engineer, I frown at the idea of 0.02. Pratik, which machine will give you second decimal accuracy, Pratik? Huh? Okay, so for example, if you're measuring the height of 10 people or 20 people, all right. So the scale can measure maximum a tenth of a centimeter or something. Just because 100 people are there and you've got a powerful calculator, you should not say that the average height of the person is 165.142. I mean, that is brute math. 165.142 is something which can be never measured by, you need even a micrometer screw gauge. I don't know whether it will do that or not. Okay, scale cannot do that. So the idea of significant figures, how many decimal numbers you'll have to hold back, that is, and because this may be very much useful from the point of computational frugality or computation economics. Oh, who is that? Crosstalk. All right. Pratik. Pratik, are you there? Hello, Pratik.
Sir, he is not here, sir. I think someone has come for something, so he is talking to him.
Okay, all right. Okay. So you tell him that I just wanted to ask him whether it's a fair criticism. All right. So now you can do the same thing and then say that the standard deviation is 7 and the mean is 62.02. So does the story end here? No, not quite. Now, what we do is we try to plot the height versus weight. So now there seems to be some correlation. So there is something cooking. So something is cooking with fire now. So we are able to see that once the height increases, the weight also increases. So it's so actually a lot of things have to be done. For example, if it is boys and girls and this thing of the same nationality, same region, so there can be many things, but we don't know the other attributes of the data. Only this very simple, we've got only the fellow, his height or his or her height and the weight. So now there seems to be some relation. So which means if height is more easily measurable than the weight, assuming that height is more easily measurable than the weight, therefore height becomes the independent variable, the easy to measure variable that comes on the x-axis, and the weight is something which you want to predict. So you want to do what is called predictive analytics. That's what these data scientists will tell you and scare you to death. Okay, you want to do this is a very desi predictive analytics. Predictive analytics is a big field by itself. So we'll get close to it. We'll also see how predictive analytics can be used in atmospheric science, climate change, and so on. All right. So now if you do this, there seems to be something cooking between these two. All right. What is that? Now, there is something called regression which you can do, which I'll explain in the third lecture 3 or lecture 4. So there is something called regression which you can do. That means you can develop, once you know there is a causality. From physiology, we understand that if somebody is having height, he is expected to have more muscle mass, this thing, bones and all that. Therefore, it is very likely that his weight will also be more. So assuming that causality is established independently of the data, so we are trying to establish the correlation between the various attributes. Now, if you do that, you're able to get something called R squared. Don't forget, worry about R squared now. It's called the coefficient of determination. The closer it is to 1, it shows how good the fit is. Now you can see that if it's a linear fit, you're getting 0.99. If it's a quadratic fit, you're able to get even even better. Okay, 0.9994. Okay, so in fact the height, it turns out that even when if you go to a fitness clinic or if you want to calculate what is called the body mass index, is basically weight in kg height whole square. The height is in centimeter. Okay, so this is, you are supposed to be less than 24.9 or whatever. Otherwise, you're overweight. Above 30, it's obese. Less than 18, you're too thin. You have to eat more. All right. So the height square is also coming. Why is that height square coming? Because of the fundamental geometry. So it goes the square of the height. So you can see that there is a relationship. But what will happen is, we should not be fooled by the data. We are unauthorized to extrapolate the data to far away from the bounds of the lower and upper bounds. For example, go back to the first plot, left side linear, and there's then you can keep on extending, and then there will be a particular height at which weight will become 0 or something. You get some nonsensical conclusions. Okay, so that the data is not suggesting. So don't try to extrapolate this. So this linear or quadratic relationship is fine within the bounds of the interval. So now with this predictive, so you have a predictive relation. You enter the height 180.3, you go to this equation, it will tell you what the weight is. So the weight is 71.4 for the linear. For the quadratic it is 72. Let's go back, turn around and see. 180.3 is this fellow, row number 14. It is 72.1. Okay. Now, thank you. Sorry. What did you do? So your idea of what is coming up. Now if you see this, row number 14 is 180.3 and 72.1. With your correlation, you're able to predict 71.4 or 72, which is not bad at all. All right. Okay. Now, tools for data science, starting from simple Microsoft Excel to MATLAB, Python, and MySQL, my structured query language. Many tools are available for doing data science. There are other considerations which are also very important in data science. For example, ethics, bias, privacy, very important right now. Okay, there is something going on in the Supreme Court, right? So there is a spying software which there's a complaint against whatever. So there is a spying software which is being this thing. Then during election time, some other software was used, and other social media giants have been accused of. Therefore, see, there is a saying there is a very popular saying now. Oh, it is Google, Gmail is free. This is free, that is free, and all that, right? So somebody said, if something is free, you are the product. That means you are being sold. What is being sold? Your attributes. You are having so many attributes. Okay, what will you buy? What is your, I don't know, credit card number, your Aadhaar number, this thing, whatever. So if something is free, you are the product. Like that. So there is a big problem of this data ethics, bias, and privacy. Okay. But right now, these are beyond the scope of the short course. This does not mean at all that these are not important. Since we are scientists and engineers, this is something which we don't often worry about. But in civil society, this will become more and more important. As data science is becoming more and more important, and people have access to data, we don't know in what all ways the data can be used, misused, abused. So ethics, bias, and privacy will become key factors in the days to come. All right. Okay, that ends lecture 1. Okay, we should have completed this the last class, but we had so many hiccups last week, so I couldn't complete it. So now this lecture is now titled data. Okay, very simple, data. All right. Okay, it is a capital mistake. What Sherlock Holmes says, it is a capital mistake to theorize before anyone has data. Insensibly, one begins to twist the facts to suit theories instead of theories to suit the facts, right? So you actually believe something, and then you want your data to prove it. that is not the way science should be done. Even our Sherlock Holmes, our friend also says that. Okay, very elementary, my dear Watson, right? So many of you remember that. So instead of theories to support facts, you'll have to twist the we begin to twist the facts to support the theories. Okay, rather the theories have to be twisted so that they agree with the data. Okay, so this is some feel good, so that before we get on to some get on to the subject, we usually start with some jokes. Okay, all right. Oh, this is very important. This is profound. Not everything that can be counted counts, and not everything that counts can be counted. I mean, it's best not to explain. You just assimilate it. Who said it? And none other than Albert Einstein. Not everything that can be counted counts. So not all the data are important, and the data itself cannot be counted. There could be the data could be somebody is angry, somebody is unhappy. So you cannot put a number to that. You can say, extremely satisfied, sir. Wherever you go now, you say Airtel, sir, give me rating, sir. When you go to service center, rating, 4-star, 5-star. Indigo, you book a flight ticket, they will say rating. Okay, everybody's, but all things cannot be counted. All right. Okay. So this is very nice. This thing from originally Netscape was very important. Netscape was a big revolutionary browser, right? I don't know, many of you may not know this. So if we have data, let us look at data. If all we have is opinions, let us go with mine. And this is how a CEO will speak. Okay. This is some Jim Barksdale. Okay. This is how a CEO will speak. Okay. Now, before we get into this chapter, statutory warning. Okay. This is from a Nobel laureate. Torture data enough, and it will confess to almost anything. I come again. So torture data enough, and it will confess to almost anything. So data analytics, data science is a double-edged sword. So you'll have to use it properly. So, and okay, it should not be the case of that you already have something in mind, you're twisting and torturing the data to prove or disprove your hypothesis. Okay, data itself will tell you so many things. So be open, be frank, have highest levels of scientific integrity, scientific conduct, okay, and integrity and honesty, so that whatever the data says, you will report. All right. Okay, data. What is data? The raw material from which information is obtained. Before doing any data analysis or extract science out of it, we need to start with the process of gathering and sorting the data. So you have to first gather and sort the data. Even before this, even before you gather and sort data, the primordial requirement is the identification of the kinds of information sources. So what is the source of this data? From where will you get this data? Where will you seek this data from? Okay. Now, data types. The data types are basically structured data and unstructured data. Let's go to unstructured data. These are data without labels. Whatever emails you're getting, the hundreds and thousands of mails, these are without labels. So it is unstructured data. Now you'll say, no, sir, I have a way of organizing it. So based on some email address of some select email address, you can create a subgroup. You can do this in Microsoft Outlook. I'm sure you can do this in Gmail. I don't know. So then you can say that, or you can say, if it comes, if email from Balaji at IITM, block it, for example. Okay. So you say that you give what is called a command. So you give a rule. Okay. But even then it is not universal. It is still, so email is basically unstructured data. Now you go to structured data. The example we worked out a little while ago was very structured order data, 15 people, ascending order, height, weight, centimeter, kg. It's all clean, clear. And when you plot the data, there is no missing data. I mean, there's no height and weight are not interchanged. Okay. So suddenly height is not in the form of an alphabet. They're all numerals, and somebody's height is believable. It is not saying 8 meters or it is not saying 1 centimeter. So the weight, everything is looks like the data is the integrity of the data is very high. It is structured and very good data. Structured data need not be strictly numbers. It could be anything. Structured data could not be. It could be text. It could be other things also. All right. So, for example, data with customer ID. Okay, your Aadhaar number, your credit card number, your debit card number, your bank account. Okay, your mobile number. They're all considered as structured data. If you put your Aadhaar number, everything will come. So your COVID registration and getting the vaccination certificate, everything, it's all your mobile, right? So all these are structured data. All right. Consider a data from a place where pressure is between 1005 and, hey, I'm not able to see that. and 1013 millibar, and there was a rainfall of 20 millimeters in the last 3 hours. Let's say this. Let's say that. Okay. 1 second. Okay. Now, however, it is not clear if a lower pressure would cause a lower rainfall, because immediately we are looking in at patterns. Hey, is there a relationship between pressure and rain? Boss, hang on, we will not come to that stage. You're just presenting some data, that's all. It is not clear if a lower pressure would cause a lower rainfall or vice versa, or if there is a correlation at all between the two. Okay. Now, challenges are more, obviously, in compiling and organizing unstructured data. Structured data is equivalent to machine language. So it is easy. For example, if there is a question paper, I am a prof, we are all the time, we are teaching and asking students to take exams and all that. If all the questions are A, B, C, D and so on, the answers are A, B, C, D, the answers can be machine read and the correction could be instantaneous. But if you ask them to write an essay, you'll have to necessarily read. Okay, you have to necessarily read. That is not a structured this thing. It is not machine readable. Okay. I'm not even trying to suggest that everything should be machine readable. From the point of view of data science, structured data is equivalent to machine language, making it easier to be processed by computers. Data collection. Okay. Open data. These data are available from governments, NGOs, scientific organizations, NASA, NCAR, whatever. Okay. IMD. Okay. Wherever. So academic and scientific communities and are usually available to all. Or even if it is restricted, this thing you say you're a research scholar working in IISc, IIT Madras, you're a prof, you're a scientist, blah, 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 you want to collaborate. Then they will ask you to register on MOSDAQ, something, and ISRO. You can download the data and use it. Example, basic weather data, GFS data, ECMWF data. If you're a health worker or something, UNICEF data about health statistics and so on, and about children. Okay. So all these data are usually open data. Needless to say, apart from being accessible, open data need to be reusable, properly described, complete, and when updates are there, there should be updates, and also there may be some support. There should be some community or user forum where I'm having trouble with downloading this data. I don't have the latest data. This browser is not working. That is not working. It's HTML. It is not compatible. If you have all these issues, there should be some support available to you to access to. Yeah, please mute yourself. Whoever it is, I'm not able to see you. Okay, thank you. Okay, so timely updates with support are also required. Hey, some of my students are there. Girish, you are there, right? Girish, Sayan.
Yes, sir. Yes, sir.
If you're able to locate somebody who is doing this thing, just politely just put it on the chat box, right?
Yeah, sure, sir.
Okay, just take care, like what we do. All right. Now, Girish will give you a Google form. Okay, please go to it will be there in the chat box. It's just basic data. So I am doing some data analysis, not data collection with you now. Good. I'm in the data collection slide. We are just getting your basic data on name, roll number, not roll name, email address, and whether you're a student or master's or PhD, whatever, and then some remarks. This basically to send reminders and course notes and all that, because I am unable to send to all at DVHR or all at COAS. All right. So please fill this out by the end of today's class. Girish, you're uploading it. You're putting it up. Mari Girish Kumar.
Yes, sir. I have up to the chat box.
Okay. Okay. Now, social media data. Social media, there's so much of data available. Okay. It's a gold mine to analyze for R&D purposes, or for other purposes also. Facebook application programming interface is one example. There are many other examples. Multimodal data. Okay. Consider the explosion of the use of IoT, the Internet of Things. In the Internet of Things, you can say that, okay, a big university has many buildings. These many buildings have this many sensors for temperature, humidity, all that, ventilation, and how many people are coming in, ingress, egress, and all that. And some will be a number counter, some will be temperature counter, some will be this thing, all that. So all this is put in the part of a building management system. A lot of data is coming, and there are security cameras where photos or videos are coming, pictures are coming, videos are playing, and temperature is coming, numbers are coming. So this is in various formats. Then you'll have to figure out whether the system is working well or not. Okay. So this is basically what IoT. This is basically IoT for a smart city. IoT, multiple sensors for a smart home. Okay. So you can, when you open the door, automatically the light will go, the lights will go glow. And you can, using a mobile app, you can say that you went on holidays, the refrigerator was shut down. I'm going to come back tomorrow. Hey, refrigerator, like, hey, Alexa, say, give me Kishore Kumar song, like that. Hey, refrigerator, switch on tomorrow. Hey, geyser, tomorrow morning, you just switch on at 5 a.m. Okay, so you can say that, all right. So just like you Dunzo something, you Swiggy something, and okay, you use Zomato food, like that you can do this. Okay, so this now the Internet of Things is exploding. Okay, so there are devices of include sensors of various kinds, as for example, multi-sensor network for a building management system, and the data just need not be just numbers or text. They can be audio, video files, images, music, use of space, and so on. After this, you have to classify the data, you have to process the data. There are additional tasks involved in handling multimodal data. Separate out all the video files, separate out all the JPEG, separate out all the MP4, separate only the audio files. Okay, then take only the temperature, take the pressure, and take the counter and this thing and all that. Okay, so then you also take, now in DVH also every day morning, suppose you automated, the temperature of everybody, all the students and scholars is being recorded. Suppose it goes to the chairman and all that. So that will be a big data. So every day, suppose you do the pulse oximeter, so that will be additional data. So this will be so many data are coming out, right? This, all right. Okay. Data storage. Data is also stored in various formats. A text, for example, is stored as comma separated variables, right? So, for example, you can also do, right? So, Balaji, I don't know. So you just say 53. So this is a comma separated variable. Okay. So all this one is number, one is age, one is sex, all that. Like this is one way of storing. Okay. There are also tab separated variables. So there are also you can also separate by means of tabs, right? They have a particular way of rating. Michael. Then there is a tab. Okay. Then 33. I don't know. Tab. Wall Street. I don't know. Wall Street. Tab. So this is how this computer science fellow, all the tab. So then you'll have to tell him. Okay. Tell him means whoever the programming. The first is the Michael name. Second is his door number. Third is the street number. Then there is a pin code. So these are all tab separated variables. Other formats, HTML, XML, JavaScript, all this basically in the domain of CS. We can't go too much into this. This just to give you a flavor of in what all formats data can be stored. Barcodes and QRs are another. Now you say you go to Google Pay, received a payment of 10 rupees for coffee by IAC students in IDC, whatever. Okay, so you do this, and then it'll GPay is done. So barcodes and QR is also another kind of data storage. Okay. Data pre-processing. Often the data collected may be incomplete, noisy, or inconsistent. So the following are required before we do any analytics on the data. Okay. So data cleaning, data integration, data transformation, data reduction, data discretization. I come again. Cleaning, integrating, transforming, reducing, and discretizing. Let us look at all the above very briefly for the sake of completeness. Okay. There can be data cleaning is the first step. There can be many reasons for having dirty data. One could be that you didn't take the reading properly, you didn't allow steady state to be reached, you were distracted, or there is noisy data, or something that day that instrument got corrupted. So it is apparent. So there can be many reasons why the particular data is dirty. Okay. So intuitively, it is quite apparent there should be as many ways for us to clean it up. Okay. Data munging or data manipulating, okay, is one of the first things. For example, let's say the dry bulb temperature at 7 UTC, okay, that is 12:30 in Bangalore on 16th January was 30 degrees centigrade, RH was 46%, and the pressure was 1004 millibar. This is basically Ramayana, like it is just text. Now you put this in a table, serial number 123, quantity, dry bulb temperature, RH, pressure. Third column, value 30, 46, 1004. Fourth column, unit, degree centigrade, percentage, millibar. It becomes very scientific. So the same thing which is presented as a text look like it was not analysis friendly. Once the moment you put it in the form of a table, it becomes what is analysis called as analysis friendly way of putting up of presenting the data. Is that okay? All right. Handling missing data. Why missing data? Lots of reasons for this to happen. Okay, missing data, that you miss that or something, there is a power cut, there is a fluctuation, something, the data logger did not work. Okay, suddenly there is a surge in the power and all that. So some data are missing, or something, the computer became cranky. Okay, the server became cranky at that, for 5 minutes data is not available. Okay, so you are doing a security check, some bank is getting looted or something, that critical 10 minutes the data CCTV coverage is not there, we don't know, they want to figure out a crime police department. Okay, so suddenly the street lights are not there, so this is not able to pick up. There could be many reasons. Okay, and particularly when they reconstruct a crime scene and all that based on assembling the CCTV footage and all that, all these things may come up. Lots of reasons for this to happen, as I just told you now. How do we deal with it? With this one simple thing is ignore the record. How many records you will ignore? So if you just say keep on ignoring it, the data scientist will be very uncomfortable. You talk to a data scientist, ignore the record. Arey Baba, already only few data are available. Or within the data, if you just ignore some attributes, then your ability to do analysis comes down. Okay. Therefore, don't try to completely ignore the record. See whether you can salvage the data. Okay, to the extent possible. Salvage the data to the extent possible. Inference based filling up is there. Can you do some smart work and fill up the missing data based on some scientific guessing? Okay, using a global constant to fill all the values. That is also one approach. That's a crude, that's a desi approach. You can use a global constant to fill up all the missing values. So all this will become very clear in a short while when we actually do a live example. Okay, noisy data. Sometimes the issue may be noisy or corrupted data. We don't know. Suddenly the temperature might have increased so much. You're measuring something. So therefore the pressure transducer or something, or the relative humidity transducer is malfunctioning. Okay. So you want to do some upper air measurement. Something is not okay. So there could be a lot of noisy data due to faulty instruments, data entry problems, technology limitations, software problem, internet problem. They often encounter noisy data. How do we deal with them? For example, simply rationalize the decimal points. I told you just now, 20 minutes ago, I just told you how to rationalize decimal points in a, not in a thermometer reading, but in a scale reading. Identify, remove outliers. Something are really, so some one reading says that somebody's height is 327 centimeters. You just remove it. It's something, it is bizarre. Okay, it is not possible. Somebody is a full grown male, weight is 8 kg or something, that is baby's weight. Okay, so if you get something like this, then immediately there's a red flag. So they are called outliers. Okay, they're completely out of the range. Identify and remove them. Let us now look at data filling, handling missing data through an example from atmospheric sciences. What happened? Right bracket, 2 right brackets are there, and left hand side 1 bracket. So this is not correct, Balaji. Yeah, okay. So something I missed. All right. Okay. What should I do now, Girish? Are you able to hear this? Can you get the sound, please?
Yes, sir. You can hear.
Yes,
Okay.
sir.
Okay.
Yes, sir, beautiful.
Okay. Now, please watch this.
Hello, everybody. My name is Patricia Sanchez, a meteorologist from the National Weather Service here in the Dallas and Fort Worth area. We actually located in the city of Fort Worth, and today we want to show you a little bit of what we do every single day. And part of that, we also release a weather balloon. So today we want to take you all the opportunity to show you how do we do it, how do we prepare it, and how do we release it every single day. So stay tuned, and we hope you enjoy it. Thank you.
So radiosonde observations are commonly known as weather balloons. So we're going to start this video explaining you a little bit what is a radiosonde. As you can see here in this picture, radiosonde is a very small box with different sensors on it, and it's actually going to be suspended over a large balloon that is inflated with hydrogen gas. This sensor can measure pressure, temperature, relative humidity, and GPS position data every single second. So we can track it from a ground antenna on a radio frequency, and we can see it on our computers in our office. Then the signal is converted to different values to get all the information that we need to put in a special code form. So I guess you have wondered, why do we need this data and how do we use it? So we need to remember that to understand and accurately predicting changes in the atmosphere, it requires a good observations of the atmosphere, and the radiosonde provides a primary source of the upper air data, and also can be applied to different efforts. And applications include computer-based weather prediction models, severe storms, aviation, fire weather, and marine forecast, weather and climate change research, air pollution models, and it gives the ground truth for solid data. So now we're going to take you to show you all the details of how do we prepare and launch the radiosonde. Stay tuned.
So here we are, we've already put the balloon on the nozzle, which is right here, and we're actually going to put a little bit more hydrogen gas than we usually do, just because it's a little bit breezy outside today. So the gas that we use is hydrogen, which is highly flammable, so we like to make sure this area, the whole inflation building, is very secure and there's nothing that's very flammable that can cause harm in the building. So once that's filled up, we attach this parachute, which will go here to the bottom of the balloon, and then this bottom part will go to the radiosonde. So this is just because once the balloon is up in the air and it bursts 20 miles up high, the radiosonde is going to fall, and we need the parachute to help it land safely. So now we'll go ahead and fill up the balloon, and we'll see you in a bit. Here we are, the balloon is filling up. I'm sure you can hear the hydrogen going into the balloon. And now it takes about 5 to 10 minutes to fill up the balloon, depending on how much gas you're putting in. So in this case, since we put a little bit more gas, it'll take a little bit longer. So now, while the balloon is filling up with hydrogen, we already have our string pre-cut. So this string gets attached to one side of the parachute, and then this string down here, this is a string that will be attached to the bottom of the parachute and then eventually to the radiosonde. Now the balloon has finally finished filling up with their 1,500 grams of hydrogen, and now we're going to tie it off because we don't want the hydrogen to escape before we release the balloon. And sometimes, probably not today since it is summer, it's usually a little difficult to tie these balloons off. As you can see, we do need to do multiple knots. Everyone has their own way of doing knots. It's pretty much as long as there's no hydrogen coming out, you're good. So we'll just do a few more knots just to make sure it doesn't get loose. Okay, so now our balloon is ready. So we're gonna go back inside to prep the radiosonde, make sure the GPS is working, the temperature and the pressure, humidity, everything. And we'll see you guys in a bit. Now we have set up the computer here to be able to track more efficiently where the balloon is going to take the radiosonde. So as you can see, since we have a south wind, we're pointing the antenna northwest. So right now we will go outside and release the balloon, and we'll see you out there.
Hey guys, we just finished, well, Bianca just finished the balloon launch, but we just want to share with you a few funny stories.
Yeah, I think that's fine. So this is how they launch a radiosonde. Okay, so that's a weather balloon. Now let's do some data analysis with this. So as these meteorologists have already told you, weather balloons record pressure, temperature, dew point, RH, wind velocity, and direction. Free to use station data from all over the world is available through the University of Wyoming, for example. There may be other sites. This is what we and my group, our group, we have been using for many years now. So actually, 2 times a day, these weather balloons are launched. Okay, so this is agreed upon. The World Meteorological Organization, WMO. Okay, based on WMO, there are stations all over the world where they launch. Okay, these weather balloons. I think it is at 3 UTC and 8:30 in the morning and 8:30 in the evening. As far as India is concerned. Okay. So these data are available, okay, for all over the world, and continuously they get updated. Okay. Now this is a sample data collected at Chennai Airport. Okay. On 27th January, this is last week. So this is an exercise I did with Baki Harish. Baki, are you there? Baki, are you there in the audience? He's not there. Girish, is he there? Hello.
No, sir, he's not this.
Okay. All right. So this is basically sample data collected at Chennai Airport. You can see the two lines. The right side is a dry bulb temperature, and the left side is a dew point temperature. So the three columns are pressure in millibar and temperature and dew point in degree centigrade. So you can see that. So this is basically what is called as QT ln P chart. So the height, height is, instead of the height, we use pressure in atmospheric science. Okay, it's quite useful because the pressure and height are anyway related by this famous. We look at the hydrostatic equation. So P equal to P naught into E the minus Z by H. Okay, so this is the pressure at MSL at ground, mean sea level. So this is the pressure at Z. So this is your height Z. It can mean any units, but the funda is Z and H must be in the same unit. Okay, height is in kilometer, and then this is basically the scale height of the atmosphere. It is also called as what is called the E folding depth. Okay, I don't want to get into detailed atmospheric science, so this is from basic atmospheric thermodynamics, you'll get it. Okay. So now if you take this P by P naught is E the minus Z by H. Okay, ln of P by P naught equal to minus Z by H. So therefore, if you take ln, so pressure is a proxy. Pressure is a surrogate or a proxy for height. Okay, so you can see that the height is invariably written in pressure coordinates, and please note that it is basically logarithmic scale and it's a nonlinear scale. So the lowest value 1000 represents the sea ground level, and then we are going up. All right, and so it is a ln P. You can see that the temperature lines are not vertical. The temperature lines are skewed at 45 degrees. So if you want to trace a minus 30 degree line, it will go from the southwest to the northeast. So this is basically to make it more presentable so that we can do more calculations. Okay, this is only for convenience. There's no need to make it as QT ln P. It could have been just T and ln P, but for some historical reasons we are doing that. So VOMM. Okay, what is that? There is a VOMM. Are you able to see the VOMM on the plot? Okay. Can somebody answer? Are you able to see that?
Yes.
Yeah. So what is that VOMM? Is basically, so this VOMM is the what is called the station code. Station code for Chennai Airport. So this is basically from the International Civil Aviation Organization. So everybody knows that VOMM means. So you're basically talking about Chennai. Okay. So and it is at 27 January 0000Z. That means it is at 5:30 a.m. in the morning, right? So now, for example, the Kempegowda, the code for Kempegowda is BLR. The London Heathrow will be is LHR and so on. So these are internationally. So you should know how people have cooperated and this thing. And so that's how you're able to get a lot of big data. I mean, so there's a lot of cooperation. So you can get station data from anywhere. Now we are going to do a simulated exercise. So we assume that this is actually the 27th ka data. Now we assume that the 27th ka data is not there. It is missing. I have data on 25 and 26. I have data on 28 and 29. So can I use some data cleaning or data filling techniques and then reconstruct reconstruct the temperature for a given 5 or 6 levels of pressure, and I turn around and see whether they actually match with the data which is available. So this is an exercise we are performing, so that we are trying to, what is the goal? To see if our data cleaning or data filling techniques are working. Is it understood? It is a simulated exercise. So it doesn't mean that 27th it was not available. It is very much available. So me and my scholar worked this out last few days. So in order to present to you a case which is related to atmospheric science and which is related to data science also. All right. Is the situation clear to everybody? Hello.
Yes, sir.
Very good. Okay. Now, possible ways of filling the missing data. Mean, averaging the observations up to a certain order. So mean is the sum of observations divided with the number of the observations. Or there is one more way, taking the median, taking the middle observation of sorted observations in ascending or descending order. But here it is tricky. It is x of n by 2 if n is odd, x of n minus 1 by 2 plus x of n plus 1 by 2 divided by 2 if n is even. It depends on how many numbers are there, okay, how many data points are there. Now let us look for the purposes of today's class, we look only at 7 levels: 1000 millibar, 914, 850, 793, 700, 600 and 500. So seven pressure levels, and this is a Chennai International Airport station. So we are now feigning, we are pretending that 27 data is very much there here. 27 data is very much there here. Now we are doing an exercise where we are pretending that 27 data is not there. Okay. 25th ka data is there, 26th it is there, 28th it is there, 29th is there. All these values are dry bulb temperature and degrees Celsius. Now, how do we fill the missing data on 27th January 2022? This is the question. Okay. Okay. How to fill the data on? This is the question which is posed to us. First method is the mean. Take the mean of 2 days before and 2 days after 27th January at 1000 hbar, for example, or 1000 millibar. Take 24 and 24.6 and 25.2 and 25.24.2. Take the average. That's 24.5. Similarly, for the remaining levels, we employ the same procedure. Okay. So now, so this is the mean method. Now I have deliberately kept the column 4 as question mark, question mark, question mark. And now we have filled it up on the 7th column with the mean with 24.5, 19.17, 15.7, and so on up to minus 2.35. Is this clear? Whatever I've done is clear so far? Is it clear?
Yes, sir.
Very good. Now we'll have to scientifically evaluate which is better and all that we'll do. Okay. Now, evaluate the accuracy of the data filling method. There's something called the coefficient of determination. So same thing, it is related to whatever, right? So that error, 1 minus sigma of the true value minus predicted value whole square divided by I of true value minus mean whole square. 1 minus. The above is also known as the norm of the sum, norm of the error or the sum of the norm of the error or the sum of the squares of the residuals. The sum of the squares of the residuals is basically the numerator. Okay. Okay. So more about this in a later class. Now suffice it for now that if r squared equal to 1, it means the best possible, and it's a very suspicious agreement between the filled data and actual data, because all the data are subject to error and different instruments are collecting and all that. Therefore, if you get r squared equal to 1, it will be fraught with suspicion. Okay. R square close to 1 is all right. R square equal to 0 is surrender. That means it's not doing it. It's all bizarre. Okay. So get a high R square of 0.995 and so on. That's good enough. That's good. Okay. Now let us use the mean method, and we have reconstructed the temperature profile. And okay, what happened? Predicted from the data filling method. So the coefficient of determination. No, wait. I'm sorry. The last column 7 is still the mean. We have not even filled it up. So the last column is simply the mean. Okay. Okay. Now we have filled it based on the funda which you have used. Okay. Which is the first 2, last 2 and all that. Okay. So that is why the now if you fill this, Now you're going to get coefficient of determination is 0.992. Now let's go to the next one. How do you fill the missing data on 27th January? The second method is basically the median method. Sort the observations on 25, 26, 28, and 29 ascending order and take the mean of the center values. So 24.2 and 24.6 seem to be the, because it's an even set, divide by 2 to 24.4 seems to be the based on the median. Similarly, for the remaining levels, the same procedure can be followed. Now, if you do this median, so this is coming like this. And now, if you same R squared, you can see that you're getting again 25, 19.2 and so on. The coefficient of determination is 0.997. Therefore, it seems that based on a median, it works better. All right. Now, data integration. Okay. So this is how you fill data. Okay, this is very important. You may feel that it is cheating or all that, whatever. It is not so, because when you're having large data sets, you'll have to intelligently fill the missing data. This is a technique which data scientists use. One of the important techniques. Data integration is basically combine data from multiple sources into a single coherent storage place. Detect and resolve data value conflicts. For example, temperature is given in millibar and the pressure is given in centigrade. Therefore, there is some gutbud there. So there's a data value conflict. Or temperature is in degree centigrade, it is or pressure is in minus, or it is in alphabet, the letters of the alphabet. So these are all data value conflicts. So resolve the conflicts. And also sometimes you may be combining Kelvin, you may be combining Kelvin with the degree centigrade and so on. So units of quantities of different databases may be different. Therefore, you have to be careful with this. Address issues of redundant or duplicate data, remove all the duplicate data. All right. Data transformation involves one or more of the following steps. Smoothing is basically remove noisy data. Aggregation is summarization or data cube construction, storing the data in an aggregate form. I'll give you an example. Normalization is basically scaling. Okay. Suppose you're looking at temperatures divided by the maximum temperature. So it will become a dimensionless temperature. Now all the temperatures will vary between 0 and 1. So it is easy to deal with numbers 0 to 1 rather than something with a lot of decimal places. So this normalization is frequently used in science and engineering. Attribute or feature construction is getting new attributes from the given ones. Can you extrapolate further and get new attributes from the given ones? That is also there. Okay. Dimensionality reduction. Tools like principal component analysis are available. I don't know how many of you know this. We have used it in the past. So this is basically called a feature. So it basically compresses the data into only basically first principal components are the most important, the second most important, and so on. And then you can reconstruct this so that so you can say that if only one component is used, 90% of the variation in the data is explained. If two components are used, 95% is explained. Three components, 98% is explained. Basically, it is basically trying to save computational storage and so on, and processing. Okay, you don't process with large number of quantities. Sampling and clustering can be used. For example, the triaging, which is used in COVID treatment now. All the patients are coming now. You just triage them. What is that? Somebody who is less than 60 years, somebody who is not having comorbidities, somebody whose pulse oximetry shows more than 94, his breathing rate is normal. So he's a fever less than 1 or 2, mild patient. Somebody is having a little bit heavy breathing, so pulse oximeter is showing 92 to 94, moderate. Somebody is having heavy breathing, low oxygen. So you triage the patients into mild, moderate, and severe, so that you can concentrate on those severe people, because the beds are limited, the doctors are limited. So you want to save lives. Okay. So this is so you want to give the most you want to give high level of treatment to the most deserving ones, or who are having high risk. Okay. So this is basically you're clustering the COVID patients into, you're putting them into various clusters. So this is basically triaging in medical treatment. Okay. Now, dimensionality reduction, basically going further, the key point is to identify redundancy in data and or create composite features or dimensions that could sufficiently represent a set of raw features. Okay, I'll do with this slide data aggregation. I will stop. We'll continue in the next class. Data cube aggregation is a very nice technique. Say 2 or 3 dimensions of the data are aggregated in a data cube. Let us say X, Y, Z are the length and breadth and height of a cuboid. let's say X is 62 centimeter, Y is 25 centimeter, and Z is 33 centimeter. In 6 bits in binary, 62 is 11111110, 25 is like that, and Z is 33. Now, if you write it like this, starting from 62, 25, and 33, you remove the comma and convert the decimal into binary. Now you can, this is a composite string which has got zeros and ones, which will not make sense to some outsider. But you know that from leftmost, the first 6 represent the length of the cuboid. The next 6 digits represent the breadth of the cuboid, and the last 6 represent the height of the cuboid. So you can process this. Now we can use this string, because the string is, it has got so much of information. It gives you the 3 dimensions of the cube. So now we can, so this is binary. Okay, this feature is something which we use in optimization in genetic algorithms. All right. So this is, so whatever I indicated above is actually a binary representation of the 3 dimensions of cuboid. So I will stop sharing now. Okay. I think still 41 people are there. Not bad. So how is it today? How is the pace? You're able to follow what I'm saying? Is it readable? The slides are clear. Can I have feedback for 2-3 minutes and we'll close? I'm not going to teach any further. Any feedback? Is this useful to you? Will it help?
Everything. Just I think when you get a high definition camera, then
Yeah.
the board will be clearly visible. Otherwise, it's workable for now.
All right. Okay. The slides are fine.
Yes,
What
sir.
about? Okay. All right. Thank you. Anybody else? Anybody else? Feel free. That's it. Is there any feedback at the chat box? Not allowed to fill the form. We are able to fill the form finally?
Yes, sir.
Yeah. All right. Okay. So next class we will see a high definition camera. So it will be better experience. So we will do some more data filling and all that. And then the 4th class onwards, I'll start some maths, but I'll try to make it as simple and but it cannot be made any simpler, right? So that's what they said. Somebody said, okay, I'll try to keep it as simple, but it cannot be made any simpler. All right. So we'll stop today. So the next class on 8th, 4:30. And all the people who attended today, you will get reminders at 4 o'clock. We'll send you the link again. Girish, you can stop the recording, Girish.
Yes, sir.
And then when I